Good morning, you guys. Okay, so for today, we're going to do the next lesson. Tomorrow, you're going to have a quiz on the 3 things we've done so far this week with a new unit with complex numbers and imaginary numbers. So today, we're going to multiply. So on Tuesday, we added, and on Monday, we learned to just what I looks like and what the circle graph looks like for the rules of I. And so now what we're going to do is multiply. And this is really fun and easy. All right, so what I did was I took examples that are going to look like exactly what you're going to see on Delta Math for practice, and I'm going to teach you kind of some of these rules, and then hopefully after watching this video it helps you with that homework. Okay, so we're going to multiply complex numbers today. All right, the first thing is we're going to fully simplify each of the following. All right, the first thing we have to do is always pull I out first. So when you're multiplying, you need to pull the I out in order to go ahead and multiply. So that's the first thing you're going to want to do is pull out that imaginary number. I don't know why I wrote the I like that, because we always write it like this. Okay. So what we have here is 6 root 5, all right, and then negative, and then this is where the I is. I is a square root of -1, right? So anytime you have a negative inside of a square root, that's who comes out. That's your imaginary number, because that is not a real thing. And so this is what the new unit's all about. When you have a square root of a negative, got to pull it out as an imaginary number. Then we can start doing things like normal. Okay, so we have negative I root 100. So nothing has changed besides the fact that I pulled out that I, which is -1. Okay. And now what we're going to do is multiply. So when we learn to multiply, right, you multiply the big numbers times the big numbers, or those numbers that are out in front of your radical sign, and then radicals times radical, and then you simplify them after, because if you birthday cake them now, then multiply, you might have the birthday cake again, okay? So what we have is -6i, right, this piece times this piece, and then we're going to multiply this piece times this piece, which would be the square root of 500, all right? So we pulled out the I, we multiplied, so 1, pull out the I, 2, multiply, and then 3, simplify. And by simplify, I mean birthday cake. Okay, and let's go ahead and while we're at it, splash the prime numbers when we birthday cake our irrational numbers. So 2, 3, 5, 7, 11, 13, 17, 19, 23, etc. Okay? All right. Now, let's birthday cake that 500, shall we? All right, what goes into 500? A 2. 500 divided by 2 is 250. Then what goes into 250? A 2. So I'm pulling out as many of these numbers as I can in any order you want to. I always start with the 2's. And half of 250 is going to be 125. And now I'm going to pull out a 5. Okay. And where is my handy dandy calculator? I can do this. So 125 divided by 5, that's going to be 25, right? Pull out another 5. Get left with 5, pull out the 5, and there's my 5 divided by 5 is 1. So 5 times 5 times 5 times 2 times 2 is 500. And every pair can come out as 1 to join this piece out here, and whatever's left over stays on the inside of the radical sign. So we're breaking this down, pulling out as much as we can and leaving what's left on the inside. So 5 and 5, 2 and 2. So we're going to pull out a 2, we're going to pull out a 5, and these are all being multiplied, right? Everything's multiplication here. I don't see any adding signs, some subtraction signs. Okay, so we have a -6i, we have a 5, and we have a 2, and then a 5 got left inside. All right, -6. 5 times 2 is 10. -6 times 10 is -60, so that would be -60i root 5. And there we are. Okay. All right, let's do this one. All righty. So what are we going to do first? We are going to pull out I. So this is 7i root 7. right? Because I pulled the negative out, so this was your imaginary number. We have an imaginary number here, so it's going to come out and join the 10. Okay, and now we'll multiply. So 7i times 10i is 70i. And then root 7 times root 100 is root 700. Oops, sorry, 7i times 10i. What's x times x? That'd be x squared, right? So I times I is I squared. Okay, now here's what's weird. This one we had an I and we left it in our answer, okay? But we have to think of our chart here. So I to the 0, if we ever have an I to the 0, that's equivalent to 1. If we ever have I to the 1, that's an I. I squared is the opposite of this, which is negative 1. And then I to the third is going to be a negative I. So we have an I squared here. I squared equals negative 1. So we have to remember, this is a new thing we're seeing here. When we see an I squared, or if we ever see anything besides I, if you see I squared, I third, I fourth, I fifth, I sixth, if you see any of those numbers, you have to use your circle graph and simplify it. Does that make sense? So anything, I2, I3, any exponential of your imaginary number has to be converted to one of its identities here, okay? So that means this is a negative 1 times 70, right? And so that's negative 70 root 700. And so the last step is obviously to birthday cake that 700. So let's see. Pull out a 2. Half of 700 is 350. Pull out a 2. Half of 350 is 175, right? Pull out a 5. 5 goes into 17 3 times. 25 5. I better be checking my math here. Pull out another 5. 5 goes into 35 7 times. Pull out a 7, and there's your birthday candle. So we can pull out a 2 and a 5. So these come out in front. These are now real numbers, and then the irrational number that stays inside is the 7. So we have negative 70 times a 5 times a 2 times a root 7. And so we have 5 times 2 is 10. Negative 70 times 10 is negative 700 root 7. And there you are. All right, let's try the next one. All right, so we're going to pull out the i's first. So we have negative 2i root 49 times a 5i root 100. So the i's are out. Now let's multiply. So negative 2i times 5i is going to be negative 10i squared. A root 49 times a root 100. Okay, here's where you want to be careful. Remember my second step, which says go ahead and multiply? I'm not going to multiply those right now. I'm going to, but I'm going to look at these first. What is the square root of 49? That's a perfect square. That's literally just a 7. And then we have that 5i, and the square root of 100 is 10. And so that saves me some time, doesn't it? All right, and now let's multiply. So remember, it has to be an a plus bi form. Okay, just in case it comes up, like if you have a number and a letter still. Okay, so anyways, so 10i squared and a 5i, that's going to be, well, what's I squared? That's negative 1, right? So negative 10 times negative 1 times 7 times 5i times 10. And that would be negative 10 times negative 1, which is 10. 10 times 7 is 70. 70 times 10 is 700. Okay. And now I have 700 times 5i. 7 times 5 is 35. Keep the 2 zeros. And we get 3,500i. Phew! You could have gotten this by going different routes, by the way. All right, I just see things and I find it convenient to do it one way, but you might have multiplied the i's and got I to the third power, went up and used your chart and put negative I, which we end up getting in our answer when we multiplied negative by negative, though it turned positive. All right, so you will get there even if you do a little bit of a different route than what I took. All right. Okay, one more. 7, negative 8. Okay, I got to pull out the I, right? So I have 7i root 10 times negative 8i root 10. Okay, so the i's are with us. They're pulled out. And now I can multiply 7i times negative 8i. It's going to be negative 56i squared. And then square root of 10 times square root of 10 is square root of 100. All right. I squared is negative 1. Square root of 100 is 10. And so what do we have here? A negative 56 times a negative 1 is positive 56. 56 times 10 is 560. And there we are. Awesome. Okay, so what's the next step? So there's how you would multiply just the complex numbers, a monomial by a monomial, right? One term by one term. Now what we're doing is a binomial times a binomial. Okay, so we double distribute, right? So what we're going to do is negative 7 times 5 and a negative 7 times 3i. And so that's going to be negative 35 minus 21i. And now we're going to multiply the i's through. 5i times 5 is 25i. 5i times 3i is plus 15i squared. Okay, and now it's all about combining like terms and making sure you have I plus bi form, a plus bi form. I squared is equal to negative 1. So now what we have is negative 35 minus 21i plus 25i and plus a 15 times a negative 1, which is going to be minus 15. Okay, and now let's combine like terms. What is a negative 35 and a negative 15? That would be negative 50. And then what's a negative 21i plus 25i? That would be plus 4i. And that's a plus bi form. And there you are there. So like I said, the only piece that you really have to remember is, we're used to seeing x squared and it just stays with us forever, right? This one we have an I squared and we have to remember to translate it to negative 1, doing our powers of i's rules. This one is the same idea here, but just notice we have to expand it. This means you have 2 of these binomials being multiplied by each other. And so let's expand it. And now let's multiply. Negative 8 times negative 8 is going to be positive 64. A negative 8 times a negative 9i is going to be plus 72i. Negative 9i minus 8 is going to be plus 72i. Negative 9i and a negative 9i is plus 81i squared. Okay. So like I said, it doesn't matter which order you're kind of going with things. Like, remember over here I talked about the I squared first, simplified, then combined. You can combine right now and do that all in one step. So I see a 64, 72i and 72i, right, is going to be 140, 70, and 70 is 140, so 144i. And then this is equivalent to a negative 1. Which means this whole piece is going to be negative 81 now, right? Because you have an 81 times I squared, and I squared is negative 1, so it's 81 times negative 1, which is being minus 81. And then we can combine these pieces here. Okay, and 64 minus 81, what would that be? Let's see. Calculator anyways. So 64 and the negative 81, we get negative 17 plus 144i. And that's a plus bi form, right? Remember, we want our piece with the variable at the end instead of the beginning, because we used to want 2x plus something, and now we have something plus the 2x. That's essentially what we're doing here. Because it's complex numbers, why not do it differently, right? Okay. Okay. So here's what I'm actually going to do. So because we are remote, and I want you guys to really get good at just this right now, I'm actually going to cut the notes here today, and I'll do the second part for your piece on Monday. Okay, so you're going to be quizzed on this multiplication, the adding you did on Tuesday, the just chart on Monday. You can use notes on your quiz, obviously. You're remote. You can send me questions if you need any. I did not put a time limit on the quiz so that you can focus on just practicing. That's why I'm calling it a quiz, because I want you to have like a quiz score for it, and I want you to treat it like a quiz. But I just really want you to practice all three of these skills. And then, like I said, I'll finish more multiplying on Monday. Okay? All right, you guys are all set. Have a great day, and contact me if you need anything.